Welcome to mathematics classes. We are in the chapter Locus. This is session 1 and 2. The aim of this session is to define locus, to represent locus of a point algebraically in the form of an equation of locus. We shall end the session with a discussion on reduction of the equation of locus into the Cartesian form given the equations of the locus as parametric equations. Concept number 1. Locus, the set of points in the plane and only those points satisfying the given consistent geometric conditions is called a locus. Another way to visualize this is that there is a point which has to move in the plane. When subjected to certain conditions, as it moves, the path followed by it is what is called the locus of such a point. We shall look at an example. Take a fixed point C and a moving point P. Now this P moves with the condition that this CP, that is distance of P from this fixed point, is always a constant. Let's call it as R. Now as P moves, satisfying this particular geometric condition, P has to move, but there is a condition given that distance CP should remain always a constant. We shall see how P moves, the path traced by P. So this becomes a circle. This fixed point is referred to as the center and this distance CP, R, which is radius. We shall look at another condition on the movement of the point P. Take two fixed points, A, this is a fixed point, B also is a fixed point. Now the condition on the movement of P is that PA plus PB is a constant. Satisfying this geometric condition, as P moves, we see that this P traces an ellipse. We can see here AP plus PB always is remaining a constant. The trace is going to be an ellipse. One more example. Here again we take two fixed points A and B. We allow this P to move. We put the condition that PA is always is equal to PB. That is, this distance always is equal to this. That is how P should move. When we allow P to move, we see that the trace of this P is going to be a perpendicular bisector of AB. So this is trace of P is the perpendicular bisector. We shall look at another situation. There is a line of fixed length, a segment of fixed length. Let's say we call that as some AB is a segment of a fixed length. Let's call it as some 2L. As this AB moves such that A is along y-axis and B is along x-axis, we try to observe the movement of the middle point of this segment AB. So here we go. We let this AB to slide along coordinate axis. So what we observe here is that the path followed by the middle point is the quadrant of a circle. So that becomes the locus of the middle point of AB.